Hey everybody, I wanted to go over some sample problems for the test, just to make sure that everybody was feeling pretty good, and so we're just kind of building through um, some of the problems here. So right now, we're going to go over sample or question 15.21 and 15.22. If you think you know how to do it, pause the video and give it a shot and see what you get. If not, watch me do the first one and try the second one, or however it's going to help you. Okay, so let me do this. So in terms of this question here, KC and KP are related to each other, and that's the learning that we need to know. Okay, what I've done is I have written on this let's do 1521 first, and the formula is KP equals KC times RT delta N. Okay. Now that formula is going to be given to you, but we know that R is the universal gas constant, which is 0.0821 liter atmosphere per mole K. Okay, that's fine. But now we go from here to this formula. So now the question asks us to calculate Kp from Kc. The only thing that we need to know on top of this is we need to know what the temperature is, and then we need to know what delta N is. The temperature is given to us straightforwardly right here in the problem. That's 500 Kelvin. But now this pesky little delta N. Delta N is the change in the number of moles. So what we have to do is we have to look at the reaction, and we have to find out how many moles of stuff we have on the reactant side. So what's the coefficient here? That's 1. And then what's the coefficient for these two things? That's a 1 and that's a 1. So then we find out, let me draw it over here. So delta N is the moles of products minus the moles of reactants. And that's only of the gas. So how many product moles were there? Well, in this case, we had 1 product mole, and we had 2 reactant moles. So this is 1 minus 2, and so delta N in this case equals -1. Okay, well, that's no problem. Okay, so now all we have to do is plug it in and chug along. So Kp equals Kc, 0.0042 times R, 0.0821, times 500. Let me get rid of this little thing here. I don't know why I finished up my parentheses, to the -1 power. So now, in order to solve this, we will do, let's go 0. So we do the parentheses first, 0.0821 times 500, all of that raised to the -1 power, okay, and then times 0.0042. So in this case, Kp equals 1.02 times 10 to the -4. Okay, no units. Now, for 15.22, now we have the same idea. We have a different temperature, we have a different reaction, and now instead of going from Kc to Kp, we're going from Kp to Kc. It's a lot going on there, Kp's and Kc's. But the formula is still the same. Kp equals Kc RT delta N. R we know. R is going to equal 0.0821 liter atmosphere per mole Kelvin. T now in this case, let's just make sure we have that right. T is 303 Kelvin. T equals 303 Kelvin. And delta N is the difference in the number of moles of gas. So, products, we have 1 mole of gas, and here we have 2 moles of gas. So again, it looks like it's going to be the same thing here. So delta N is 1 minus 2, because this was products minus reactants. So 1 minus 2 is negative 1. So now we plug in. And so just be careful here, because it's not exactly the same as the last one. Now we have this one, 3.34.5 equals Kc times 0.0821 times 303 to the negative 1. Oh boy, okay. So now we have to do the math here, and so we're going to do 0.0821 times 303, okay, that raised to the negative 1 power, and now to solve for Kc, we divide by this. So we do 34.5 divided by all of that, and we get 858.2 equals Kc. Kc. And so that's a pretty big Kc. So anyways, so there it is, how to do conversions between Kp and Kc. Hope this helps out. Hope you get the right answer.